You're listening to the Future Tech Health Podcast with Richard Jacobs. Until I reached age 40, I never realized the obvious, that we all have medical issues, or we at least have a family member or close relation that had, has, or will have them in the future. Medicine and biological systems are the final frontier. Until we've conquered death, figured out how life began, cured cancer, and understood our purpose in the universe, there's a heck of a lot to talk about when it comes to our health. Future Tech Health means I'll be covering futuristic topics that are actually already in clinical trials, or even starting to appear on shelves or by prescription, or available for your own use. We dive deep into stem cells, CRISPR-Cas9, the science of sleep, epigenetics, medical testing, cancer, ketogenic diets, stem cells, aging, regenerative medicine, and more. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a serious medical problem. Remember, however, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and share it with friends. Thank you. Hello, this is Richard Jacobs with the Future Tech and Future Tech Health podcast. And I have Benjamin Koetz. He's in the Science Applications and Climate Department, Earth Observation Programs at ESA, the European Space Agency. So, Benjamin, thanks for coming. How are you doing today?
I'm good. Thanks for inviting me.
Yeah. Well, when I think about, ESA or NASA or the other agencies, I don't know, somehow I guess I always think of them going out into space or observing other planets and everything. But is your focus more observing things that are happening on Earth from space, from orbit, or what's your focus at ESA?
Well, ESA is it's a space agency who's covering all the different space aspects which you can think of. And yes, space exploration is one of the most visible ones. But in fact, at the European Space Agency, the biggest directorate is the Earth Observation Directorate, and that's the one I work in, and there we really look down to Earth. We are trying to observe our little blue marble and trying to understand how it functions and give information and continuously monitoring the different processes and information coming from what is happening on Earth, from the nature, but also the activities of us people in this kind of ecosystems. That makes it quite exciting to watch it.
So what kind of observations are you in charge of, or what are you focusing on in particular? What are you observing about Earth?
All right. So my position is called the application scientist, which means nothing in the first place, but actually has the purpose of interacting between application and science, making sure that the Earth observation science is somehow related to useful applications on the ground, meaning that information from the satellites is being translated into something which is useful in managing our natural resources. So that could be all kinds of things ranging from agricultural type of monitoring up to flood disaster monitoring applications. So that is the type of range where we look at, and there's a number of different types of observations, and we can go through the different techniques which we are using, which is optical up to microwave, active or passive radars. But the technology is not the driver. It's more what type of information can be used by people on the ground to make their, let's say, operations and their applications more informed and more efficient.
Okay. So in particular, what is the focus of the observations? Are we looking at how forests are changing on the Earth, or how water is moving or changing, or is it climate observations, or all of those things? What are some particular observations that are going on?
Yeah, in general, the big advantage of Earth observation by satellites is that you have a global view about what things are changing. And as you said, changes are the most interesting one. It really is, what if a forest being cut, sometimes in a normal process, forest companies are owning and managing forests. In some cases, it's illegal cutting. In some cases, it's damage from a storm. All these kind of changes we would like to see, and because it's a resource which is valuable, forest has biomass, has value also in an economical sense. We would like to follow that and to see how it's being used. And in the context of climate change, forest is a carbon sink, so you also want to see that, how that is changing. Is it diminishing or it's increasing? And there's even a seasonal change over the seasons and over the years as well. And all that is something which you can see from space and the global scale. And that is the temporal and spatial dimension is the interesting part where you can combine space and link it then to what we do on Earth.
Okay. So what are some of the big trends that we're seeing through observation? Anything interesting or good or bad?
That's a difficult question. And the climate change context, that is certainly something which you can very quantitatively measure. For example, the sea ice is diminishing in an alarming scale. That certainly is something which has been observed by both from the European Space Agency, but also from NASA side, and it is something which is absolutely alarming. And what happens around?
Well, you know what? I want to ask you, like, what have you seen with your own eyes when you've looked at imaging data? You yourself, what have you seen that stood out to you or surprised you? You know, we all hear about scientists see this or scientists, claim this, but you being one of them, what have you seen literally by looking at data, at images?
Well, me personally, I'm focusing a lot on agriculture context, and there you see a lot of changes going on in terms of responding to lack of water, for example. That's something which we have observed in the northern Europe last summer, for example, that suddenly all the crops were being dying from lack of rainfall, precipitation, and that was something which was associated directly to climate change, variability, and that you see if you look at these images, you compare from 1 year or even from the month beforehand, and even with your, as you say, bare eyes, basically, and you see it turning from green to brown, which you see on the ground in one hand side, but if you look at on the whole continent, down to 10-meter resolution, you really can quantify this kind of impact in almost real time. That is quite, it's alarming to make the link to what is lost in terms of harvest and resources available to basically eat.
Yeah, I've heard just anecdotally in the news, and I've seen also, for instance, I live in Texas, and when we arrived here like 5 years ago, there was a drought for many years in one particular area, and then there was so much rain that the drought completely was reversed, and the local lake was filled up. It was like 80 feet down, and it was filled all the way up, which was really dramatic. And I know, for instance, again, this is the U.S., but in Southern California, there was a drought for years and years and years, and I personally observed all the vegetation dying along the side of the highways, and I remember my wife said, "Oh, when it rains, everything's gonna, there's gonna be mudslides and all that." She was right. It just started happening.
Absolutely.
And I've heard X number of years ago about Europe and Central Europe and Asia having a winter where temperatures didn't get above 0 Fahrenheit, negative C for weeks and weeks. So I've seen and observed a lot of extreme climate events. And I wanted to see what you've observed and seen, and how that affected you.
Mm-hmm. Well, that was one example I just brought up. But we have a climate change initiative as well, who's bringing this into context over 30 years, and that is much more, let's say, relevant in scientific terms. But as you said, it's the real impacts on individual like your wife is about having access to the water in your, let's say the next water pond, or on the field where you grow your crops. And we have been working, for example, in Mali. One thing what is happening in California in terms of drought, you have a certain infrastructure around, but we have been also doing this kind of things in the Sahel zone, as I said, in Mali, and there people live, they're depending on the field, and that's also something that you can directly follow from the satellite what is happening, and with that also linking it to food security type of interventions. And that's certainly important when it comes down to people who are like WFP, the World Food Program, who's organizing their food security emergency intervention on the ground, and they need to decide what place to go first and how much they have to plan 2-3 months in advance. This is the type of thing where satellite images can make a difference and help affected life in a pragmatic way.
Well, if there's really nothing we can do about the weather, but are you able to observe patterns, from space that we can't see on the ground to help people? Let's say, I live in a certain place and we're hit with a drought this season. And obviously I really want to know, will that be the end of the drought, or will it continue for how many more years? Is there any way with our observational data for you to do better predicting trend-wise, even to look at, again, just large trends and to tell farmers in certain areas or people that live in certain areas what's coming or when things will end? Or is it really unpredictable?
There is, predicting is one thing, forecasting is another. Weather forecast. We have something. You switch on your television every day, and I'm not an expert in weather forecast itself, but what I am always being told, 60% of the information which goes in the weather forecast is coming from satellites. Otherwise, that forecast accuracy and the probability would be much lower than what we have today. So that is, we do see global and regional patterns in terms of the weather formations moving along over our globe, which would not be able to be done in the same way as from ground stations. And that is also Earth observations coming from the geostationary satellites above the equator, giving us every 15 minutes observations over the full globe. There's satellites like that from NOAA over the United States, but there's also from EUMETSAT over the European side of, or European African side of the hemisphere. And these all together, there's data being exchanged between the different agencies to make sure that the weather forecasts are more predictable or more reliable. And these are patterns which you would never see from the ground, for example.
So what are some interesting patterns, like macroscopic patterns going on that we've been able to observe now with our satellite coverage?
Observe where, you say? I'm sorry, I didn't get that.
With the increased satellite coverage, what kind of new patterns or trends are we observing now? Any macro trends that are clear that are going on?
I mean, there's for example, that's another topic, but it's a clear pattern which you see in terms of increased sea surface temperature. That is something which you can always see in connection with different phenomenon like the El Nino, which is currently not very active, but it was a year ago. It was quite active, and that is something which you could link, for example, over the global distribution of coral reefs, where you see clear trends of increased sea surface temperature, which affecting the coral reefs and make them also die and or bleach, and then that means also losing the symbiosis with the reefs. That is a very ongoing trend, and it has been also documented by the IPCC report from the climate change community.
Okay. And then in terms of the work that you're specifically involved in, what's your goal? Is your goal to focus on agriculture and study what's happening with it and how to improve it, or what's your specific goal of the agency there?
Our goal is basically to, on one hand side, to develop the right technologies, and that is really the Earth observation satellite technologies, in response to make sure that these technologies fits to the information needs on the ground. And if I give you a very specific example in this case, in the context of agriculture, is that agriculture is in many cases irrigated. I mean, if you look, I think you sit in Texas, right? And you have a lot of perhaps you're not really in the focus of the Corn Belt, but still in the Midwest of the United States, you have a lot of corn being grown, which is normally irrigated, and that needs, in most cases, 70% of the fresh water which is available, and that is driven by the evapotranspiration coming from the crop. That needs to, if we can measure that in a consistent and operational manner, we can give the farmer some information about how much water was lost and how much the next day he needs to replenish by irrigation. And for that, the US, NASA, USGS has the Landsat satellite, which has a thermal band to measure the land surface temperature. That also can translate to evapotranspiration. That is done at 100-meter resolution, which is suitable for the US size of fields. If you want to do that in Europe, the fields are much smaller. So what we do in the moment is developing a satellite which is doing exactly the same type of observation in the thermal wavelengths. It's about 50-meter resolution, which is 4 times as higher resolution what is existing in the moment, in which that we could respond to increasing water scarcity in Europe, European agriculture production systems.
Okay.
So that's one example is how we develop technology and translate it into information which we could use by farmers in this case.
And what's the resolution right now of satellites? What's the smallest feature size can they see?
In the optical, in the different wavelengths.
Oh, that's true. That's true. Yeah. What? All right. So that's true. What? So it's useful to. I'm just thinking about the visual spectrum, but right. What spectrums are you imaging in, and what's the resolution of the different spectrums, and what do you see by looking at the different spectrums?
Right. Okay. So the visible one, which is the most obvious one, which we as humans observe in the natural way, is there's commercially available. We go down to 30 centimeters. That is a very high resolution satellite, which is not giving on a consistent level the global coverage every day, or it's sampling the Earth only. Then you have other satellites which actually are observing every 3 days, every day at 3-meter resolution. And finally, it's still commercial. And finally, then we have satellites which, for example, European Space Agency or NASA is building for open, freely available access. They're in the range of the 10 to 30-meter resolution. That's in the optical. And then we would like to look into other spectral bands where, for example, in thermal, there we talk about 50 to 100 meters. In many cases, 1 kilometer resolution, because the energy is lower, which we are receiving at the satellite. It's more difficult to have higher resolution information. And then finally, which is also very interesting, is the microwave region, where we have radar or SAR instruments, which can give you information up to 10-meter resolution as well. They all have different applications. If I give you an example for the SAR, for example, it's very sensitive to water surface versus land. So you could very easily observe a recently flooded area, and that you can do even through closed clouded atmosphere, which normally happens when you flood.
Oh, okay.
That's very particular for that type of observation.
What kinds of weather would get in the way? So if there's cloud cover, that's essentially water in the way of you observing the surface, right?
Right. Yeah. Well, vapor. Yeah. Water vapor. Yeah.
Vapor. Okay. Well, please continue.
Yeah. Which is basically for the optical. I mean, you're blocked. Huh? There's no way how to look through it. But the microwave information has a longer wavelength and is not affected by the water vapor, so it looks basically through the clouds, and it's a way how to still observe the Earth below a completely cloud covered area. It's just related to the length of the wavelength and related to the very small size of the water molecules. So it's not in a vapor form. It's not being affected.
Okay, got it. So microwave, visual, which is optical, thermal. Any other observation bands?
There's relatively new type of application and observation, which is called which is using lasers. That can be it's an active observation. You send out a light impulse, and then you receive this active emitted information signal back. So that is, as a system, it's called a LiDAR, based on lasers, and that can be used either to measure the atmospheric composition, but also what has been just launched by JPL on the International Space Station is a LiDAR system which can measure the height of the surface, the Earth's surface, but also even distinguish between the surface of a tree canopy and the Earth below. And that gives you the tree height, for example, and you get a three-dimensional representation of the surface, which is a relative, it's a completely different type of observation, which I have not, which is complementing the other type of observations I just mentioned.
Okay. The holy grail of the space agency would it be? I mean, maybe we can. Can we image the entire Earth and piece together enough satellite feeds to see literally the entire Earth all at once and over time?
Well, that it certainly is in the moment a big push for getting more information in a continuous way. We have been getting information, let's say, every week, every month or so, but there's a huge push now to really have the temporal dimension being covered as well by satellites. For that, whole constellations of satellites are being built, not only single satellites, and that is certainly a holy grail to really understand our activity as humans, but also the nature in a temporal continuously manner, because the changes, as we said in the very beginning, are driving our decisions on the daily level. So we want to know if there are changes out before our door, but also on the other side of the world. If you want to understand, for example, the economics of how people, let's go back to agriculture, the production in China for a certain crop is affecting the markets in Chicago and the stock market also. So you want to have this type of thing followed as continuous as possible.
Okay. Again, is it far away, or is it possible? Will it be possible soon, again, to image the entire Earth all at once, over a period of time?
But how you frame
down to some reasonable resolution. I should have qualified. Let's say in any particular spectrum, I guess there's different levels of it. So, the entire Earth down to 1 meter accuracy. In the visual spectrum where it's allowable with cloud cover, or the entire Earth, into X meter accuracy in the thermal spectrum. I mean, how far off are those abilities?
Well, what we at the European Space Station Agency are doing, we do it every 5 days at 10 meter resolution. So that's existing already, and that is open and free for everybody. In the commercial world, there's the company called Planet. They have about 120 small sats or CubeSats flying, and they observe the world per day in a 3 meter resolution. But it is not something which you do at once. You need to have a whole fleet of satellites to do that. So 140 small satellites doing that, and you have to stitch it up together, which in the end you don't care about because you get this information. But it's not something that you do with one snapshot. So that is how things are moving. And if you want to have 1 meter, it's a question of money in the end to invest. It's technically possible. You just need to have a fleet of satellites who's capable of doing that. And as I said earlier, there are satellites already who do samples of the Earth at 30 centimeters.
Would there be any big benefit in being able to do, the entire Earth continuously, or no?
There will be any data?
Any benefit? Would there be any benefit from being able to continuously, view the whole Earth?
It depends on what process you want to look at. I mean, some of these very frequent data we just talked about is being used, for example, to monitor the changes, how often the Walmart parking lot is being frequented, and make some analytics on that, how well the business of this Walmart is happening. If you are ready to pay for that and you think this is valuable for your business decisions, then this is a benefit. You need to always think about what is your process you're interested in, and you will come up with that. And there has been over the last few years, a huge, let's say, understanding what the monitoring and the temporal information dimension can bring to communities which we have not been talking to on a regular basis. When we talk to climate change scientists, that's not necessary, the type of frequencies you need. But if you talk to Bloomberg, they are interested how the, let's say, the oil reserves in a particular country is changing, and there is a way how to assess that with very high resolution satellites on a frequent basis now. Okay.
Well, very good. So where can listeners, and I don't know if there's a public repository or if there's a level of public access for some of these images, some of the satellite data, but whether there is or isn't, where can the public learn more and find out more about what kind of imaging is going on?
There's, many of the satellites are public, available, and open. Some of them are commercial, so they are not necessarily for free. There is what we call the CEOS, that's the Committee of Earth Observation Satellites. It's an organization of all space agencies around the globe, and I think this website is ceos.org, where you can get a full repository of the existing satellites flying in the moment, and there are the hundreds and more, where you get their specifications, the availability, and the data where you can get them to download them. So that I would point you to this, let's say, repository to understand what is existing.
Okay. Well, very good. Well, Benjamin, thank you for coming, and I appreciate you being on the podcast.
Thanks again for inviting, and it was a pleasure as well for me.
You're listening to the Future Tech Health Podcast with Richard Jacobs. Until I reached age 40, I never realized the obvious. that we all have medical issues, or we at least have a family member or close relation that had, has, or will have them in the future. Medicine and biological systems are the final frontier. Until we've conquered death, figured out how life began, cured cancer, and understood our purpose in the universe, there's a heck of a lot to talk about when it comes to our health. Future Tech Health means I'll be covering futuristic topics that are actually already in clinical trials, or even starting to appear on shelves or by prescription, or available for your own use. We dive deep into stem cells, CRISPR-Cas9, the science of sleep, epigenetics, medical testing, cancer, ketogenic diets, stem cells, aging, regenerative medicine, and more. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a serious medical problem. Remember, however, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and share it with friends. Thank you.